We have talked about the area of a bunch of different objects, and so now we are going to start talking about the volume of those different objects. So we're going to start with 9.8, the volume of rectangular and triangular prisms. Volume is used to measure the amount of space inside of a three-dimensional object. So if we were to look at how much space we could fill into a rectangular prism like the one below, how much could we put in there so it would fill up all the space? That is what volume is. So volume is always measured in cubic units. Area is measured in squared units. Volume is in cubic units. Our general formula for volume is the base, which is the area of the base, times the height, which is the height of our prism. Okay, so if we scroll down a little bit, we look more specifically at a formula for a rectangular prism. So here, for a rectangular prism, the volume of our base, or volume of our prism, is base times height, where our base is length times width, because that is the area of our base, and then times the height of the prism, which is the distance in between our two bases. So if we look at the example below, it says find the volume of this rectangular prism. We have our length and our width. Our length is 10 and our width is 5. And then our height in between the two bases is 5. So in order to find the volume of this prism, we are going to plug in our length times width times height. When we do that, we get 10 times 5 times 5. And that gives us a total of 300 centimeters cubed. Example number 2 says that the volume of our rectangular prism is 682 millimeters cubed. Its length is 10 millimeters and its width is 20 millimeters. We want to find its height. So if we know our volume equation is length times width times height, and we plug in the values we know 682 equals 10 times 20 times our height. We can simplify that a little bit because we know that 10 times 20 gives us 200 times h. Get rid of that 200 to get our h by itself. We can divide both sides by 200. And we are left with 41 millimeters is equal to h. Okay, so now that we've talked about rectangular prisms, let's look at a triangular prism. And again, you have to draw this triangular prism in on your paper. So if we have a triangular prism that looks like this. Okay, so this is our triangular prism. We're going to have right angles in the corner here. In our triangular prism, we have our height of our triangular prism, the base, and the length. So in this case, remember our general equation for volume is the base times the height. The area of our base in this case is 1/2 base times height of our triangle. And the height, which is the distance from between bases, is our length, our L. So this is our equation for volume in a triangular prism. So if we look at example number 3, it says to find the volume of this triangular prism, and hint, use the Pythagorean theorem to find h. So if we have our given information on here of 10 centimeters along this side, our L is 15 centimeters, our B is 6 centimeters, and that is all the given information it gives us. So it tells us, hint, use Pythagorean theorem to find h. We have a right triangle, we know our leg B is 6 centimeters, and our hypotenuse is 10 centimeters. So when we set up our Pythagorean theorem, a squared plus b squared equals c squared, we can plug in what we know. We know our b is 6, our a is still unknown, and our c is 10. Subtract 6 squared from both sides. A squared equals 64. Take the square root of both sides to get a by itself, and we get a equals 8. So now we know our other leg here is 8. We can figure out what the volume of our triangular prism is because now we have all of our information. We know that our formula is 1/2 base times height times length. Our base is 6, our height is 8, and our length is 15. Plug that into my calculator, and I get 360 centimeters cubed.